Hello, good morning children. In the previous class we have seen Gauss chart method. So were you able to follow finding Gauss chart, inverse using Gauss chart method? So today's class let us enter into application of matrices. So where are matrices being applied? Where these matrices are being applied. So now here we are going to see system of linear equations. And suppose if a statement is also given, with the help of statement, we are also going to form a system of linear equations. So system of linear equations already you have learned in a 10th standard. So 10th standard first, a linear equation is being introduced in your 7th and 8th standard, finding out an unknown value for one variable. So if you have a linear equation in one variable, you will be solving for that and getting the result. Next, when you upgrade to 10th, you will have a linear equations in two variables. You will solve using different kind of methods for two variables. So hope so in 10th standard you would have learned solving simultaneous system of linear equations using elimination method, substitution method and cross multiplication method. So you would have used any one of these three methods and you would have got the solution for the system of linear equation. Now the same system of linear equation, now since we are being upgraded to 12th standard, we are going to learn the same system of linear equation. We are going to use matrix methods to solve the same unknown values. Suppose if we have 3 unknown variables x, y, z or 2 unknown variables x, y, we are going to solve using matrix method. So how to go about? Now suppose if I have a 3 equation, some for example x plus y plus z equal to 6. So 2x minus y plus z equal to 3. 5x plus 2y plus 3z equal to 0. Now this is a system of linear equation involving 3 variables x, y and z. Now the same kind of equation now we are going to solve using matrix method. Now here in matrix method, however number of unknown I have, that many unknowns can be found. So a general form of matrix method is A11x1 plus A12x2 plus etc. plus A1nxn equal to B1. Now A21x1 plus A22x2 plus etc. plus A2nxn equal to B2. It goes on because you can have any kind of matrix. AM1x1 plus AM2x2 plus etc. plus AMnxn equal to BM. So this is also a system of linear equations where the unknown values are x1, x2, etc. xn. Now b1, b2, etc. bm are constants and a11, a12, etc. you have till amn, or those are the coefficients of your x1, x2 goes on till xn. Now this system of linear equations, how we are going to solve? Now here also, if I have an equation like this, my coefficient of x, y, z will be taken into account. I am going to solve for x, y, z and my constants will be 6, 3 and 0. Now here, A11 now the coefficients of x1, x2 till xn. So I have A11, the coefficients of x1, x2, etc. xn. So we have a system of linear equations. I am going to write the coefficients of x1, x2, etc. xn. So a11, a12, etc. a1n, a21, a22, etc. a2n, etc. am1, am2, etc. amn. Now this matrix is called as a coefficient matrix, where the order of this matrix is a m cross n matrix. M cross n matrix, and this matrix, the coefficients of x1, x2, etc. xn, since we are writing in this parenthesis, this matrix is a coefficient matrix. Now I am going to solve for x1 is to till xn. So x1, x2 till xn. How many rows I have? N rows. So n cross 1. I have only one column where I have n rows. So this is an unknown matrix where we are going to solve for x1, x2, etc. xn. Now the third thing is, I have the right hand side constants b1, b2, etc. bm. Since I have bm, this is also I have too many rows, but only one column. So automatically this becomes a column matrix. So here my order is m cross 1. Now this is a constant matrix. So with the help of this, I am going to write ax. I am going to multiply with this coefficient matrix with this x, where I get again my system of linear equation where we have already written, that is a11, a12, etc. a1n, a21, a22, etc. a2n, etc. am1, am2, etc. amn. I am going to multiply with an unknown matrix x1, x2, etc. xn. So if I multiply again, I get back my original system of linear equation. So row by column multiplication, a11 x1 plus a12 x2 plus etc. plus a1n xn. Okay. So a21 x1 plus a22 x2 plus etc. plus a2n xn, etc. am1 x1 plus am2 x2 plus etc. plus amn xn. Now this is my ax. This is my original system of linear equation what we have written first. That is equal to my matrix B, B1, B2, etc. So I have, now I have multiplied matrix A along with matrix X. So now I have Ax equal to B. Now this is my matrix form, where the matrix A is called the coefficient matrix and matrix X, xn, etc. xn is an unknown value that we are going to solve, and this is called as the constant matrix. This is called as matrix form. Now suppose if I am going to augment the value of constant together with the matrix coefficient matrix, that is called as augmented matrix. So augmented matrix I have in the form of a11, a12, etc. a1n, a21, a22, etc. a2n, etc. am1, am2, etc. amn slash my values of constant matrix I need to take along with the negative sign, not only the coefficient along with the sign. So minus 5 here, plus 7 here, 2. Similarly, in the third, I have 6, minus 3, minus 8. This is my coefficient matrix A. I have 3 unknown variables x, y and z where I am going to solve, equal to my constant matrix. Here my constant is plus 7. If I take the right side, it becomes minus 7. Here already I have 17, so write 17. Here plus 24, if I take the right side, it becomes minus 24. So now my matrix form is of the form Ax equal to B. So I have written the given system of equations in the form of Ax equal to B. Now, if I am going to solve for x, y and z, that becomes the solution of the given problem. That becomes the solution of the given problem. What are all the different kinds of solutions we have? Already you have learned in 10th standard doing graphs. When you have two linear equations, you draw graphs for both the linear equations and you may get a solution or you may not. Suppose if two lines, I have a graph, okay. Suppose if two lines intersect at a point, I have two lines include adding two variables, two linear equations having two variables. If both the lines intersect at a point, we say this is the point of intersection and this is the solution for the given graph. If two lines they intersect at a point, so automatically that system is consistent. That system is consistent and it is said to have a unique solution. You have only one solution for this. Now suppose if I have a graph like this. So here also xy, here also you have x and y. Okay. Now suppose if I have a line, say for example, let me write the equation as 3x plus 2y equal to 5. This is my first equation. So, as far as this graph is concerned, if I go with the example of an equation, you will be able to understand in a very better manner. So, 3x plus 2y equal to 5. Now, 6x plus 4y equal to 10. Fine. So, definitely you can see some connection between these two equations. I have 3x plus 2y equal to 5, 6x plus 4y equal to 10. Definitely can you see some connection between these two equations? Now, look at the second equation. Is my second equation some multiple of first equation? Hope so you are able to follow. Or second equation, if I am able to divide by 2, what do I get? I get the same first equation. So automatically, both the lines represent the same one line. So I can have here infinite number of solutions. I can have here infinite number of solutions. And both the equations are coincident. Here also the system of equation is consistent and since both the equations represent one line, you have infinite number of solutions. Now what is the third kind of graph? So is that possible that I should always have a solution? Why not I don't have a solution? Let us see. I have x and y. Now here also, let me go ahead with some example. Here both the line represent same. My coefficient of x, coefficient of y, everything is same. But they differ only in the constants. So this kind of equation, they represent parallel line. If two lines I am able to draw, Definitely not. So parallel lines, if they never intersect, automatically here we don't have solution because there is no common point between both the lines. So there is no point of intersection. So here the system of equation is inconsistent and they possess no solution. They possess no solution. So a system of equations is said to be consistent if they possess at least one solution, and if they don't possess any solution, the system of equations is said to be inconsistent. Inconsistent. Now already I told you we are going to write in matrix form A is equal to B, all those. Suppose if my constants everything is 0, all my constants are 0, I have at least only with the coefficient of x and y. So those kind of equations are called as homogeneous system of linear equations. If at least one of my dA value is non-zero, that kind of linear equations are known as non-homogeneous system of linear equations. Now let us proceed on with the solving of system of linear equations using matrix method. What are the different methods we are going to use? First one is matrix inversion method. Matrix inversion method. So with this method, in exercise 1.3, we are going to learn this method solving system of linear equations for unknowns. Second is Cramer's rule. Cramer's rule. Then the third method is Gaussian elimination method. Gaussian elimination method. Follow. Now first, what is matrix inversion method? For matrix inversion method, my matrix A, the coefficient matrix, first thing, it should be a square matrix. It should be a square matrix. Then, it should be a non-singular matrix. It should be a non-singular matrix. When can you say that the matrix is a non-singular? When can you say a matrix A is a non-singular? We have already learned. So, matrix A is said to be non-singular if determinant of A not equal to 0. So, when do inverse exist? When do inverse exist? And inverse exists if A is only a non-singular matrix, which means determinant of A should not be equal to 0. So, A is a non-singular matrix and it should be definitely of a square matrix, and if determinant of A not equal to 0, my A inverse exists. So, if A inverse exists, automatically I have A inverse equal to A inverse A equal to I. This we have already learned. Whatever may be the matrix A, if we are able to find out inverse of that matrix and multiply both matrix A with inverse, definitely I get the identity matrix I. Now, I have my matrix form as Ax equal to B. Let me pre-multiply by A inverse on both sides. Pre-multiply. Pre-multiply means you are going to multiply before. Post-multiplication you are going to multiply after. So, pre-multiply by A inverse. So, A inverse of Ax equal to A inverse B. Now, using associative property, you group A inverse A and x equal to A inverse B. Already we have A inverse A as I. So, identity matrix multiplied by x gives to A inverse B. Nothing but I into x. Identity matrix if I am going to multiply with x, same x I am going to get equal to A inverse B. Now suppose if I have Ax equal to B, so my values of x unknown which I am going to solve is A inverse B. This is called matrix inversion method. So matrix inversion method, if suppose two equations or three equations are given, you are going to solve using this formula. So solve by matrix inversion method. If suppose a question is, automatically you go ahead only with the formula of x is equal to A inverse B. So now let us get into the problems of how to solve system of equations using matrix inversion method. My first question is 2x plus 5y equal to minus 2, x plus 2y equal to minus 2. I am going to write this equation in matrix form. So first my matrix A is coefficient of x and y. So 2, 5, 1, 2. My x is unknown matrix x and y, and my g is minus 2, minus 3. So matrix form is Ax equal to B. I am going to solve for x. My x is equal to A inverse B. Already we have learned A inverse in our first exercise itself. So what is A inverse? A inverse is 1 by determinant of A into Rj. Okay. Now what is determinant of A? First we have to check out whether the determinant of A is non-singular. Only then A inverse exists. Otherwise we don't have solution for the given equation. So determinant of A is determinant of 2, 5, 1, 2. So if I proceed finding the determinant, 2 2s are 4. Since I go in the reverse order, I have minus 1 5s are 5. Now 4 minus 5 is minus 1. Now this is not equal to 0. So definitely A inverse exists. Now as far as 2 by 2 matrix is concerned, we can write adjoint A directly. Or suppose we go for the cofactor matrix. Then cofactor matrix, if I take transpose only, I get adjoint. But as far as system of linear equations, if I have only two equations, if I have only two variables or a 2 cross 2 matrix, 2 cross 2 matrix, I can definitely find out adjoint A directly. Let me tell you how it is. So adj, how to find directly? Interchange these two elements. Okay, the main diagonal, you interchange the values. The remaining two elements, you take only negative, that's all. So 2 and 2 becomes 2, 2. Now 5 becomes minus 5, 1 becomes minus 1 in the same place. Because plus minus minus plus. And if I take transpose, I get this. If I take transpose, I get this. So only for a 2 cross 2 matrix, I can find adjoint A directly. Now let me go ahead solving for x is equal to A inverse B. First, what is A inverse? 1 by determinant of A. So 1 by my determinant of A is minus 1 into Rj. 2 minus 5 minus 1 2. Here itself, let me take this negative 1 inside. So I have minus 2, 5, 1, minus 2. Now x is equal to A inverse B. So minus 2, 5, 1, minus 2. I am going to multiply the constant matrix minus 2, minus 3. So my value of x here is x, y equal to, I am going to do row column multiplication. minus 2 into minus 2 plus 4 minus 15. 4 minus 15. Second row minus 2 plus 6. Minus 2 plus 6. So value of x, y equal to 4 minus 15 is minus 11. 6 minus 2 is 4. So my solution is x is equal to minus 11. Y is equal to 4. Follow children. Let me enter into the second problem. 2x minus 4 equal to 8. 3x plus 2y equal to minus 2. So my matrix form is Ax equal to B. So my A is 2 minus 1, 3, 2. My x is same to unknowns x and y I have here, and my B is 8 minus 2. Same way here also I am going to start using matrix inversion method. So formula for matrix inversion method is x is equal to A inverse B. X is equal to A inverse B. Okay. Now here also I should check for determinant of A. Determinant of A is not equal to 0 only A inverse exists. So what is determinant of A? Determinant of 2 minus 1, 3, 2. So here 2 2s are 4. If we go in the reverse order, already I got minus. So this becomes plus 3 into minus 1, so 3. Reverse order minus, 3 into minus 1 minus. Minus of minus becomes plus 3. So 7 not equal to 0. So A inverse exists. Now here also I can find adjoint A directly. How to go about? Only interchange these two. I have only 2's. Minus 1 becomes 1. 3 becomes minus 3. Transpose of the adjoint matrix is adjoint. Now A inverse equal to 1 by determinant of A into adjoint. 1 by my determinant of A is 7. My adjoint is 2, 1 minus 3, 2. I got my A inverse. So now shall I proceed for finding x? Fine. So x is equal to A inverse B. My A inverse is, I have 1 by 7. So equal to 1 by 7. Now only in the final step, last step we will take this 7. In the previous problem, since I had only minus 1, I have taken minus 1 directly inside, which is easy for me to multiply with the matrix B and get the solution directly. Now here, if I take this 7 here, you can take no problem. But definitely you may go wrong somewhere. You will get confused somewhere. So if you have any number other than 1 or something, keep that number as such. We will proceed only in the last step, which makes your problem easier. So 2, 1 minus 3, 2 with the constant matrix 8 minus 2. Okay. So same way here also let me apply row column multiplication. So 2 8s are 16. 1 into minus 2 minus 2. Minus 3 into 8 minus 24. 2 into minus 2 minus 4. So 1 by 7. 16 minus 2 14. Here minus 28. Now my x is x y. So x y equal to, I am going to divide this. 7 2s are 7 minus 4s are. So what is the solution for my problem? Value of x is equal to 2. So my solution is x is equal to 2, y equal to minus 4. This is my solution for the second problem. Let us get into the third problem. 2x plus 3y minus z equal to 9. X plus y plus z equal to 9. 3x minus 5 minus z equal to minus 1. Here we have 3 unknowns, x, y and z. So here also we are going to start using matrix inversion method. So let matrix form is Ax equal to B. Now what is my A? 2, 3 minus 1. Coefficient of x, y, z. Z minus 1. Coefficient of z is 1. Here, everywhere it is 1, 1, 1. Okay. Here 3 minus 1 minus 1. My x, I have 3 unknowns x, y, z. And my b is 9, 9 minus 1. So here also we are going to find the determinant of a. If determinant of a not equal to 0, then A inverse exists. Let me find determinant of A. So 2, 3 minus 1, 1, 1, 1, 3 minus 1 minus 1. So here 2 into minus 1 into minus 1. Minus 1 when you go in the reverse order becomes plus 1. Minus 3 into deleting this column and the row, I have minus 1 minus 3. Same way here, minus 1 into minus 1 minus 3. Here 1 minus 1 0, 0 into 2 automatically it becomes 0. Minus 1 minus 3 minus 4. Minus 4 into minus 3. Minus 4 into minus 3 plus 12. Minus 3 into minus 1 minus 4 into minus 1 becomes plus 4. So 12 plus 4 is 16 not equal to 0. So my A inverse exists. Now since I have here a 3 cross 3 matrix, I have a square matrix with 3 variables, 3 cross 3 matrix. Is it possible for me to find out the adjoint A here directly? Definitely not. So only for a 2 cross 2, it is easy for me to find adjoint. For a 3 cross 3, I need to go with the cofactor matrix, and taking transpose of the cofactor matrix gives me adjoint. Let me go ahead with the cofactor matrix. Cofactor matrix is denoted as Aij. Okay. Now I have, let me take even this. Let me have first element. Deleting the corresponding row and the corresponding column. I have positions plus, minus, plus, minus, plus, minus, plus, minus, plus. First is positive. Now here minus 1 plus 1. Okay. Now here minus of this, deleting this row and this column. Minus 1 minus 3. Now here plus minus 1 minus 3. Now here minus of, I have position negative. Deleting this row and this column. Minus 3. Minus 3. When you go in the reverse order, I have negative. But already minus 1 into minus 1 plus 1. So minus 3 minus 1. Minus 3 minus 1. Now here I have plus. Deleting this column and this row. Minus 2. Minus 2. Reverse order negative. And minus 3. So plus 3. Minus 2 plus 3. Now here also negative. Because here my position is A23. A21 negative. A22 positive. A23 negative. So deleting this column and this row I have minus 2. Minus 2 reverse order. So minus 9. Minus 2 minus 9. Now same way A31 positive. Deleting this row and this column. 3 plus 1. A32 negative. Deleting this column and this row. 2 plus 1. Same way last element A33 positive. 2 minus 3. Now I have 1 minus 1 0, minus 3 minus 1 minus 4 into minus plus 4, minus 3 minus 1 minus 4, minus 3 minus 1 minus 4 into minus plus 4, 3 minus 2 1, minus 2 minus 9 minus 11, minus of minus 11 plus 11, 3 plus 1 4, 2 plus 1 3, but I have negative minus 3, 2 minus 3 minus 1. Now what is my adj? Aij over transpose. Transpose of this cofactor matrix. How do you find transpose? So my adj, how do you find transpose? Row, your first row becomes first column, second row becomes second column, third row becomes third column. Or first column becomes first row, second column becomes second row, third column becomes third row. So 0, 4, 4, my first row, first column change into first row. 4, 1, minus 3, minus 4, 11, minus 1. Now let me find the unknown value 6. X is equal to A inverse B. Now what is my A inverse? 1 by determinant of A into adj. Now what is my determinant value? 16. So 1 by 16 here adjoint A. 0, 4, 4, 4, 1 minus 3, minus 4, 11, minus 1. Now let me proceed finding the values of x, y and z. So I have x, y, z equal to A inverse B. My A inverse is 1 by 16, 0, 4, 4, 4, 1 minus 3, minus 4, 11, minus 1, multiplied by my constant matrix 9, 9, minus 1, 9, 9, minus 1 equal to 1 by 16 into same way row column multiplication 0 plus 9 4s are 36 minus 4, 4 9s are 36 plus 9 1s are 9, minus 3 into minus 1 becomes plus 3, minus 36 plus 99 plus 1 equal to 1 by 16, 36 minus 4 32, here 36 plus 9 45 plus 3 48, 99 plus 1 100, 100 minus 36 gives me 64. I have here x, y, z. So my x, y, z equal to 16 how many times 32? 2s are 16, 3s are 16, 4s are. So my solution is my value of x is 2, y 3, z 4. This is my solution for a 3 cross 3 square matrix using matrix inversion method for the given set of equations. Now, so I would have we have seen nearly 3 problems of same kind using matrix inversion method. So with the help of all these 3, I want you to work out example 1.2 to 1.23 as well as exercise 1.3 first sum, fourth subdivision. All these 3 problems I want you to complete as homework. Example 1.2 to 1.23, exercise 1.3, first sum, fourth subdivision. Complete these 3 problems as homework with the same model, same method. No change anywhere. Suppose if you have any doubts,